What's up, everybody? It's Greg Peters with the Car Passion channel here, bringing you a little update on what some people consider the world's least reliable Miata. But I like to remind those people that, to my knowledge, this is one of the only BP-powered Miata builds that's response-focused and also crests 500 horsepower. Response-focused meaning it can do more than just 60 rolls and impressive dyno pulls. I can daily drive it down to the local taco shop or take it on a casual or not so casual canyon run. It's certainly not the highest horsepower BP ever built, but to make it more of an all-purpose build, I'm running an absurd combination of 12-to-1 compression, stock cams, 24 pounds of boost through a turbo running at its maximum rated RPM to the far right side of the compressor map, and a lot of ignition advance on E85. This results in a reasonably impressive, for a BP, 400 foot-pounds of torque at the wheels at just 4,200 RPM, and north of 350 foot-pounds of torque all the way from 3,900 through 7,500, which makes for an extremely fun street car, and that's all I've ever really wanted from it. But it also makes for a ton of cylinder pressure, and that's kind of the foundation of this video. Now this one's going to be a little long, a little chatty, and I'm going to go in depth on some tuning topics, and I know these videos aren't for everyone, but you can check out the segmented time bar down below and search around the video if there's something in particular that you're looking for. So without further ado, let's jump into it. So my car has developed a bit of a head gasket issue where it's pressurizing the cooling system. And the video where I talked about this recently was actually not the first time that it happened. It happened about a year prior when I took the car drag racing with throttle, but I just figured it probably just got hot and overwhelmed the radiator cap, or maybe the radiator cap was making a bad seal, because it ran completely fine after that and for several months until I took it on a canyon run and it did the same thing again. But once again, I just figured, it probably got hot, overwhelmed the radiator cap, whatever. It ran fine for several months, didn't fill the overflow tank, etc. This was all on the Vulcan cut ring head gasket, for context. But eventually it started filling the overflow tank during normal driving, and I did a leak down test which showed that cylinder number 2 was leaking combustion pressure into the cooling system. And without much investigation, I said, you know what, I'm just gonna send it. I brought the head to the machine shop, got a fresh cut on it, installed an MLS head gasket, and slapped it back together. And it ran great, except I did make a slight mistake by using too thin of a head gasket compared to the previous one, and since my engine has pistons that actually protrude out of the block and into the head gasket area, they made friends with the cylinder head, but just barely and only at full boost. It only happened a couple times. There were a couple witness marks, but no real damage. And I know people were asking, well, what about the rod bearings? Are they okay? I don't know, and it doesn't really matter at this point. I'm not going to tear the engine apart to find out. I slapped another MLS head gasket in, this time with the proper thickness, and that brings us to where we are today. And I switched over to the MLS because I figured, you know what, I might have to pull the head on this thing more times, and I don't want to have to get it machined every single time I pull it, like you do with the Vulcan cut ring gasket. So after that head gasket install, I immediately took it out and turned it up to max power, which I verified by a new personal best 60 to 130 mile per hour time of about 7.3 seconds. And it lifted the head immediately and blew coolant all over the windshield. So that brings us to today. Now the good news is the car still runs just fine, and it actually passes a leak down test with flying colors, which means that it's technically possible to lift the head and not blow your head gasket. At least that's how it seems so far. The lame part is I've found the mechanical limitation of something, whether it be the MLS head gasket, the Apex head studs, or possibly a combination of both. So I've been talking with Boffy Racing and a few others, and the conclusion that we're coming to is most likely it's the peak cylinder pressure that's just too high for the combination of parts in this specific engine. And it's, again, the combination of high compression, stock cams, and a decent amount of boost and ignition timing all combined together that's leading to this. Now, I know I already said this, but I just want to reiterate, I'm well aware that this is not like a record amount of horsepower for the BP platform. People have done 700 and more, nearly 1,000 I've seen. So it's not groundbreaking just for the horsepower number, But one problem with those builds is they're just not that well documented, and there's not a lot of information online to do research from about them. Like, what combination of head gasket and head studs are they running? What does the torque curve look like on the dyno? And most importantly, how many passes, pulls, or miles do those cars actually survive without needing some kind of rebuild? My point is, relatively speaking, maybe these issues that I'm having are more common than people think on BPs making more than 500 horsepower, because where are the accurate documentations saying that it's not true? Where are the other people that are running 500 and more, documenting their entire build and actually posting all the problems that they've had and what the solutions may be for those problems? Anyways, I digress. It seems to be that the issue is just generating too much torque at too low of an RPM for the combination of parts that's in this engine. What's going on? Are we in danger? Who's out there? Woof. Okay, I was just kidding. Why so serious? Generally speaking, making more torque at lower RPM is harder on parts than making torque at higher RPM. And if someone can reference to me, someone who's making more than 400 foot-pounds of torque at 4200 on a BP, I'd send them my way because I'd love to have a conversation with them about their engine, their tuning strategy, etc. So a solution for the problem I'm having now that could involve just tuning rather than building an entire engine might be to lower the ignition advance through that peak torque area, which is between 4,000 and 5,000 RPM, and leave the boost the same. What this should do is just make the combustion event a little bit later in the engine cycle, and that should lower the peak cylinder pressure in that RPM range. On paper, this is a great solution, but in practice, it didn't work out exactly how I was hoping. So I took the Miata out for some full boost pulls with a good amount of ignition advance taken off the table. And one thing you'll hear about in the tuning world is it takes some figuring out to see what an engine likes as far as a combination of AFR, boost, and timing. All this means is it's not necessarily about the mechanical limitations of the parts in the engine or necessarily the knock threshold of the fuel. It takes some experimentation to find out how much boost and timing the engine is going to make the most power and be the most efficient on. Some engines just like more timing and less boost. Some like more boost and less timing, or a combination in between. You've probably seen this in one of my tuning videos at some point where we add 2 degrees of ignition advance and all of a sudden the car made 40 wheel horsepower and the torque curve, and the torque curve smoothed out. We say, okay, the car liked that timing advance. And then I'll add another 2 degrees and the car only makes 3 more horsepower. There's no reason to add that last 2 degrees of timing because you're just adding danger, making it more knock prone, and you're not gaining anything from it. So during those pulls with reduced timing between 4 and 5,000 RPM, the engine did not like it. And I don't mean like it just blew up. I can't even say for sure what phenomenon was occurring, but I could feel in that range that the engine was struggling somehow, like it was misfiring, kind of like it was blowing out spark, which shouldn't really be happening when you're lowering the boost pressure. But I could see in the data logs that both the boost and RPM were like jittery through that RPM range, which, come to think of it, it actually sounded kind of like compressor surge, which could be the issue. Compressor surge is always more prone to happen at a lower RPM than a higher RPM, and with more boost than less boost. Technically speaking, it's more prone to happen with a higher pressure ratio at a lower airflow. Anyways, that's a big tangent. I have a video on how to read compressor maps. If you're interested in compressor maps, I'll link that video down in the description below. Regardless of what is actually occurring in that RPM range, I know that if I run full boost and timing through that RPM, I run too high cylinder pressure and I overwhelm the head gasket or the head studs or both. Doesn't matter. Something's getting overwhelmed. If I run full boost and less ignition advance through that area, the engine doesn't like it either, especially if it's getting compressor surge under load, which can be much more destructive than the type of compressor surge you hear when you don't run a blow-off valve. So I think the solution here is just going to be to leave the ignition timing alone, but lower the boost level just through that mid-range and then start ramping up boost and timing once the engine passes 5,000 RPM and starts to drop its volumetric efficiency. So I still get that savage top end, and even from 5,000 RPM, I still have another 2,500 to 3,000 RPM left, which is a big chunk of the power band, depending on how hard I want to push that Maruha stroker crank in RPM and power, because nobody really knows where they fail at yet, since it's a cast chromoly crank instead of a forged crank. But I can assure you that they take 500 all day. So let's jump into Tuner Studio real quick, and I'll show you the issues I was having with boost control trying to achieve this and the eventual solution that I came up with. And this could help someone with a variety of setup. You don't have to have some high horsepower build to be able to utilize the stuff I'm about to show you. So let's talk about boost control tuning real quick. Okay, here we are in Tuner Studio, and with closed loop boost control, you can have boost by TPS and boost by RPM, which is exactly what you see here. These are the KPA targets. You can see at lower throttle, we're targeting much lower boost, and at lower RPM, we're not targeting too much boost because an issue arises with that I'm about to tell you about. You can also set up boost by gear. And with boost by gear, you can tell the ECU to target a certain boost level depending on what gear you're in, and also tell it, okay, ECU, only target these boost levels when you're above this much throttle percentage. So at low throttle down in here, it's going to use this table. And then as soon as you go above 50% throttle or whatever percent throttle you choose, it's going to automatically just target whatever value is here. And it actually ignores this table completely. So there's no way to run boost by gear and boost by RPM, because say I wanted to limit boost to 235 kPa in the mid-range right here. So at full throttle, it's going to limit boost to 235, and then between 5,000 and 6,200 RPM, it's going to ramp the boost up to 260 kPa. Normally my boost targets in 4th and 5th gear are 260. So I floor it at 4,000 RPM, okay? Which according to the table is gonna target 235 kPa, but since I'm floored, the ECU automatically goes to the gear target and it's gonna target 260, which is what I don't want. Another issue I have with this is if I'm in 4th gear at a much lower RPM, say down here, the reason I have this target lower is because I know the turbo cannot generate full boost at 3,200, so I have my target set lower. The problem is when I go above 50% throttle, ECU is targeting 260 kPa, which is 24 pounds-ish. The turbo can't generate that boost down here no matter how much I floor it. It doesn't matter. So turbo's trying to generate boost. The ECU says, hey, we're not hitting 260 kPa. It doesn't know about RPM. It's ignoring that because it's targeting the per gear boost target. We're not hitting 260 kPa. We need to raise the duty cycle on the boost controller like crazy, and it will max out the boost controller to try to target that 260 kPa. And by the time the engine comes up in RPM, where it can actually achieve that 260 kPa, the boost controller is cranked up super high and it will go to like 300. It'll go to 30 pounds of boost even when the target is only 24 because it doesn't have time to react and see that the turbo is coming on way too fast. So those are two issues that you have to deal with where either your boost by RPM or boost by gear target is taking priority. But I emailed DIY AutoTune about this, and they have a genius solution. I actually suggested implementing a new feature where you could control the boost by gear target to only activate at a certain RPM. And they said, you know what, there's already a solution for this that people are using. So let me show you guys what that looks like. If I come over here to boost table switching and I go to blend curve, we can do something pretty trick. Gonna open up my boost curve blend here, and I'm going to open up boost control target table 2. Okay, yes, that's right. Sorry, this is like the first time I've kind of messed with it. These settings are not correct yet, but what you can do is you set the x-axis parameter to gear, and I open this little table down here. So now x equals gear. So we're just gonna go 1, 2, 3, 3, 4, 4, come on, 5, and then it's only a 5 speed, so we can just do all 5s here, doesn't matter. The percentage is now, okay, I can fix these axes later. Hold on one second. Okay, here we are. So I can set one of my tables up to be the boost that I want to run in first gear, right? Which is approximately 5 pounds of boost. That's the wastegate spring pressure. I then set the second boost control table to the boost that I want in fourth and fifth gear, which has this nice curve where we have lower boost in the mid-range, 4,500. Actually, this should be 4,000. Where we have lower boost from 4 to 5,000, and then after 5,000, it ramps up to higher boost. And again, this is not even tuned yet. This is just conceptually to show you what we're doing. Then down on this curve here, we're going to say, what percentage of the second boost control table are we going to feed in by gear? And what that means is in fourth gear and fifth gear, yeah, it's kind of confusing because this table is bigger than it needs to be because it's kind of multi-purpose. In fourth and fifth gear, we're going to 100% blend the high boost table. But in third gear, we want less boost. I might only want to blend at 75%. And in second gear, maybe like 40%. It will blend between these two tables. The only downside, it's not really a downside, I think it's going to work out just fine, is as it starts blending, it's also going to blend in a boost ramp in every gear. So second and third gear are also going to have a boost ramp where they don't really need it, but typically you're going to have traction issues when you first go into a gear anyways, rather than up in the higher RPM. So I think it's going to work out just fine. Anyways, I was super stoked on this solution. It's a totally different option if you want to set up boost by gear, and then actually you're going to take boost by gear and turn it off if you use this situation. This is going to take a lot of trial and error and testing to get just right, but it's freaking cool. So now I can do boost ramp by gear. Okay, I know that was a lot to take in and probably completely irrelevant to a lot of people, but if you do have any questions about it, just drop them below in the comments and I'll do my best to get to them. Let's move on to the new sensors that I've installed on the Miata's engine to help monitor this ongoing situation and do my best to keep this engine safe while still generating a ton of power. And as we get into sensors, I would like my patrons to sense my gratitude for their support each month. You guys are all on screen right now. Thank you so much for the support. And if you're interested in joining the Car Passion Channel Patreon, details to that and much more can be found in the description of this video. So back to the actual sensors. Number one is a coolant pressure sensor, which you probably guessed, measures the pressure inside the cooling system. I've now set the tune up so that when the pressure in the cooling system comes up to or gets close to the cap rating, it will go into a limp mode, which I tell it exactly what to do in that limp mode, and I'll get an immediate warning if the pressure starts to go too high, where before I would just be full send, I would pressurize the cooling system, the overflow tank would completely fill up, overflow, and then the wind would carry that water all over my windshield, and then I would know, Houston, we have a problem. So this is going to be a much, much earlier warning, just in case I push this thing a little bit too hard, or if I do end up blowing that head gasket, which is a total possibility, but I'm trying to play it a little safer than I have in the past. In order to wire up this sensor, which I'll link below, the one I'm using, you just need a 5-volt source, ground, and then a signal line, which is going to go to your standalone ECU. And pro tip here, I don't know if my car has like a wiring gremlin or if you just can't do this, but I tried to hijack the 5-volt source from the throttle position sensor, and when the coolant pressure sensor was plugged in, the TPS would only read 60% in Tuner Studio. So that obviously messed up the tune. In order to get the best and most accurate data from your sensor and not mess anything else up, it's best to run a 5-volt source directly from your ECU, which any standalone ECU should have that. And then you can just ground it to any standard engine ground, or even better, the sensor ground, which can be found also at the ECU. And then you run the signal wire from the sensor to the ECU. If you're using MS Pro like I am, you can use this chart that I have on screen right now to figure out which pin you're going to use. And you need to remember where you pin it in because you're going to need that information in just a minute when you open up Tuner Studio to actually set up the sensor. All right, we're back in Tuner Studio here. Let's go ahead and get a fresh start. And I'm going to show you exactly start to finish how to set up this sensor and really any pressure sensor or almost any sensor in general that you're adding to your engine and plugging into your ECU. The first thing you do is come up to Advanced Engine and go to Generic Sensor Inputs. I already have it set up here, but let's go through what the process is. I pinned my signal wire into analog in 1, so it's going to be analog in 1. You can name it whatever you want so you remember what sensor is what when you go into this menu. I know from the data that came with the sensor itself that it's a linear readout. And in the sensor data, it showed that at 0.5 volts, the sensor would read 0 psi. And at 4.5 volts, the sensor would read 100 psi. But you can't put that information in here, 0.5 and 4.5 volts, because the software is asking for 0 volts and 5 volts. So you can either do the math and see that, okay, from 0.5 to 4.5 is a total of 4 volts, and the range is 100 psi, so it's 25 psi per volt, and do the math that way. Or in this software, they make it real easy for you, and I can just put in the data that came with the sensor, which is 0.5 volts, 0 psi readout, 4.5 volts, 100 psi readout, and it tells you the information to put in the tuning software at 0 and 5 volts, which is negative 12.5 and 112.5. So we'll do negative 12.5 and 112. Oops, that is not what I wanted. 112.5. And then for the lag factor, the minimum you can put is 15. I went with 15. It helps with a smoother sensor readout, and I don't really need like crazy fast readout from this sensor. So now Megasquirt knows how to read the sensor. So you're going to burn that, close it. I'm not going to cover adding the gauge into the dashboard because it's like a whole process. You just right click, go to designer mode, and then you can add gauges and title them and color them and do whatever the heck you want with them. But that's not what I want to dive into in this video. For the fail-safe setup, it's actually a little interesting. I couldn't find anyone who had done this before. I feel like coolant pressure sensor is probably not too common in Miata applications, but you cannot set up limp mode for generic sensors, but you can set up limp mode for oil pressure. So instead of oil pressure, since I don't have an aftermarket oil pressure system, I'm going to use the oil pressure limp mode or fail safe for my coolant pressure. So just open up oil pressure. I know it's sensor 3, which is analog input 1. It's confusing, but analog input 1 is the pin. Sensor 3 is the slot. So you're going to put the slot here. Sensor 1, minimum pressure that you're ever going to see in your cooling system is going to be approximately 0 psi. And then I want it to go into limp mode if it reaches the pressure of the cap. So we can just go here and do equals 18.5 psi. You can do RPM based if you need to, but anytime the coolant pressure goes up to 18.5, I want to know about it. I don't care about the RPM. I do not want the engine to shut down, okay? We don't want to create a dangerous situation, but I do want it to go into limp mode. So if you come to limp mode here, oil pressure triggers limp mode. You're going to turn that on, and most likely if I pressurize the cooling system, it's going to be on a pull. So we're going to be at real high RPM and boost, and I'm just going to say, go ahead and limit the RPM to 3,500. So it's essentially going to be like it's adding a rev limiter. And yes, if you're smashing corners and you hit this limiter, it could upset the car. So you have to use your discretion on how you want to set this up. You shouldn't be pushing your car so hard on the street that if you lost power or had a misfire or something, you're going to lose control of it. But just keep that in mind. So I haven't had a chance to test this out yet because I haven't pressurized the cooling system, but in theory, this should work. The ECU has no idea what type of pressure I'm monitoring, if it's oil or water, so I think we should be good. Okay, I know we're getting into the woods here, but not a lot of information about this stuff online that I could find, especially platform specific, so hopefully it's going to help someone out there. The second sensor I've added, finally, is a knock sensor. Now, I am brand new to knock sensors and using them and tuning them, so I'm no expert, but I can certainly get you started. I am using an OEM Miata knock sensor in the OEM location, which, in my opinion, not a bad way to go. I did have to extend the harness to get the signal wire all the way to the ECU, which normally would be easy, but knock sensors use a specific type of signal wire. They use what's called a shielded wire, which through a little bit of surgery on the stock harness, I figured out that the signal wire is a normal insulated wire, and then that is wrapped in an uninsulated grounding wire. So what I did is I took a long strand of wire and I stripped all the insulation off of it, and I took those strands and I wrapped it around another insulated wire to do my best to replicate the factory harness, and it seems to be working as intended. And I think that's just to limit the amount of interference as much as possible so the knock sensor gets the cleanest signal. Now, a knock sensor is essentially a microphone that you can tune to listen to a very specific frequency, very specific sound that's made by the engine during a knock situation, which is essentially uncontrolled combustion that can cause a lot of engine damage. So even though I can't give you the perfect settings, I can show you how to set this up in Megasquirt. Oh, and the wiring itself, very simple. You have just those stranded wires that go around the main signal wire. At the end of that, it actually just turns into like a normal insulated wire, just a little guy about this long. And then I connected that to the sensor ground at the ECU. And then the signal wire again goes to the option port on the knock pin. All right, we're back in everyone's favorite screen here at Tuner Studio, and I'm gonna show you how to set up your knock sensor start to finish. Notice I said set up, not tune. There's a distinct difference there, which I'll talk about in just a second, but you're gonna come up to ignition settings and go to knock sensor settings. I have mine set up in safe mode, and you can read about safe and advanced modes down here. Tuner Studio is great with having these little question marks everywhere and they tell you exactly what you're setting up. So I have mine set up for safe mode. Input type you set to internal, and Megasquirt will automatically figure out if you're using knock pin 1 or knock pin 2. Then it grays out all this stuff because you don't need to do anything with it. Here you can set up if you want to monitor knock per cylinder, but I have this turned off anyways. If that sensor picks up any knock, I want it to take action. And the rest of this stuff is actually more like knock sensor tuning. So you're telling it how much ignition advance do you want it to pull, how quickly do you want it to pull it, how quickly do you want it to feed that advance back in, other important things. When do you want it to start monitoring for knock, and when do you want it to stop monitoring for knock? And the limited testing I've done, I've seen that my engine makes a lot of just noise in general above 6,000 RPM, and noise meaning the knock sensor is picking up a lot of just general noise above 6,000, but the signal is pretty clean up to 6,000. So I have mine set up to run only to 6,000 RPM. I might try to dial that in a little bit later, but for now, the engine just gets too noisy and it's like picking up knock when I don't believe there actually is any knock. And you can do ignore during flat shift if you have like pops and bangs, not because it's going to possibly think your engine's knocking when you're just on the flat shift or on the launch control. So you can say, hey, you want to ignore it or not? Then over here, you're telling it per RPM, what knock percentage do you want the ECU to recognize as actual knock? Because as you can see, based on this signal, which is just the car idling, it's reading a percentage of that specific frequency that it's looking for. So obviously this engine is not knocking while it's just sitting here idling. So you wouldn't want this to be 10% because 10% is like a totally normal value. And then as you drive the car, you might see 20%, 30% just during normal cruising. Under high boost, high load, you might see little spikes that go up to 75%. So you might say, you know what? Everything over 65%, I want you to consider knock. And this can be a curve because the engine generally does get noisier the higher the RPM is, and you don't want it to pick up things that aren't actually knock and start pulling timing for no reason. Another very important part is knock sensor parameters. So the bandpass frequency is actually super easy to figure out. This is the frequency that microphone is listening for to try to identify as knock. And every engine is going to make a little bit different frequency, and it's simply based on the cylinder size. So you can come up to this knock frequency calculator from a website called Formula with a PH. I'm going to put in my piston size, which is 84 millimeters, and it tells me the knock frequency is going to be 6.8 kilohertz. So I'll hop over to here, and it does give you just very specific values. 6.94 is the closest to 6.8, so I'm going to select 6.94. Integrator time constant, honestly, I have not looked too far into how to tune that. Number of sensors, 1, obviously. Monitor per cylinder off. I've seen people do monitor per cylinder on, and then they set up, this is the gain. So it has to do with how far each cylinder is away from the knock sensor. Again, not too sure on the tuning. I'm just describing kind of what all these settings are. So when you're tuning your own system, maybe you might get a little better understanding from this video. Next thing is knock window. I'm going to open up these tables because it makes it a little bit easier to understand what's going on. So the top chart here is you're telling when the knock sensor to start listening for knock. Now, knock typically happens somewhere between just before top dead center and around 20 degrees after top dead center. So a general safe setting to do for this would be like, say 6 degrees. So -6 degrees. No, equals -6. So it'll start listening for knock only 6 degrees before top dead center. And then it's going to listen for knock for a total of 26 degrees, which means it's going to start at -6 and listen all the way to 20 degrees. This makes it so that microphone is only listening for knock during the time when there's most likely going to be knock, because you don't want to listen to other noises outside of that window. You want to keep the signal, again, as clean as possible so it's accurate. And the last thing is knock coolant scaling, which is just telling the ECU, hey, the engine when it's cold, it might be a little bit noisier than when it's warm. You might have a little bit of piston rock if you have forged pistons, or the lifters might be a little louder. And it's just saying, you know what? You don't have to listen quite as closely when the engine's cold. And honestly, you shouldn't be smashing on your car when it's cold anyway, so shouldn't be an issue. This video is so long, I feel like I'm losing my voice. Okay, as far as the actual tuning of the knock sensor, telling it what to listen for and when to listen, and telling the ECU exactly what to do with the ignition timing, that takes some trial, error, and every pro has their own way of approaching it. Fortunately, there is a load of information online about knock sensor setup from places like HP Academy, just all over YouTube, miataturbo.net, the MS Extra forums, depending on what type of media you like to consume. So this is where I will set you free. The quest for the ultimate BP-powered street car continues. Thank you for coming to my TED Talk. I hope you learned something from this video, got some kind of enjoyment out of it. And I will see you in the next one. Peace out.